Okay, so you should have gotten a lot of sheets in front of you, starting off with your yellow assignment sheet. So when I'm going to be taking a look at your yellow assignment sheet, this is what I have pulled up on the board here. We have taken our Unit 1 test here, and this worksheet, the Ray Flube worksheet number 1, you have not gotten this yet. Because we had to take that pre-test today, we won't have time to do it today, but we'll save it for another class, whether it be a warm-up or a stinger. So we will be doing this at some other time. So our worksheet number 1, this will be on a different day. All right, so you don't have to worry about that. Okay, and then today you'll see we're covering a lot of things. We're doing worksheets 2, 3, 4, and 5. 5 is indeed your homework here, and I went ahead and already passed that out to you. And then worksheets 2 and 3, these are notes, and 4 is a classwork activity. So again, depending on time, we might do 4 on a different day, but you will eventually get all these sheets. Okay? So let's go and take a look at worksheet number 2. All right, so worksheet number 2 looks like this. Where we have, this is actually a foldable. So what we have is that you can go ahead and fold this in half, hot dog style. So I want everyone to go ahead and fold it in half, hot dog style. And you'll see that it folded down this middle line here. And so you can open it up and see that commutative property is that first tab, associative property, that second tab. So these lines here are actually for you to go ahead and cut across only on the commutative property, associative property, identity property. If you not cut all the way across, then that means you're just going to separate into 6 little strips of paper. You only need to cut across right underneath commutative property, associative property, so that each little flap can be opened up. All right, so I'm going to go ahead and pass out some scissors just around the classroom for you to be able to cut those. But make sure you're passing the scissors along once you're done so that others can go back.
First next to person goes next to the bottom scissors.
So again, you're taking your sheet and you're only cutting this first piece here where it says commutative property. Down to the crease so that I can open that up as a flap and read what we know about commutative property. Okay. So we're cutting like this, and you're doing each flap. Okay. So while you're cutting that, we're going to go ahead and fill out the notes as well. All right. So today we're talking about properties of real numbers. And I know we briefly talked about imaginary numbers before, but real numbers is what we're working with in Algebra 1. So that's your whole numbers. It's like 1, 2, 3, 4, 5. That includes decimals, like 1.286. It includes the negatives, it's like -8, -7.3. It includes irrational numbers, so decimals that continue on forever, like pi. It just does not include imaginary numbers, which is something you'll deal with in Algebra 2. You don't have to worry about that for now. Okay? So these properties, commutative property, associative property, identity property, inverse property, multiplicative property, 0, and symmetric property. These are the 6 properties we're going to be talking about today. And the SOL loves to ask you questions on these. These are important to know the names of for the purpose of testing, but it's more important to know these properties just when you're doing problems. When we apply the commutative property, you're not necessarily going to think to yourself, oh, by the commutative property, I know that I can switch my letters, but you'll think to yourself, oh, I know that 2 plus 5 is the same thing as 5 plus 2. So you need to know the terms because Virginia deems that it is necessary for you to know those terms, but you're not necessarily going to be thinking in those terms when you do the problems. All right, so our first one here is commutative property. And I'm going to write the properties on the smartboard up here because you can't see the flap as I go along, but you have your flap, so you don't write commutative property. So this first one is commutative. All right, and the commutative property allows us to switch the order. As you'll see here, it says order doesn't matter. So for addition, what we have is that A plus B is the same thing as B plus A. So for example, 2 plus 5 is the same thing as 5 plus 2. This one's pretty simple. We have this is also true for multiplication. A times B is the same thing as B times A. Or you can think of it as AB is the same thing as BA, because remember that's multiplication. So 4 times 3 is the same thing as 3 times 4. This is true also when we have the variables. So 2 times x is the same thing as x times 2. And remember in mathematics, the proper way to write a variable and number is this way here, where you put the number first. But we've talked about when we multiply x times 2, that same thing is just 2x. Alright, so notice order doesn't matter. So all we do for the commutative property is change the order. And notice the commutative property only applies. This is only true for addition and multiplication. It's not true for subtraction. Because think about it. If I had 9 minus 3, this is not the same thing as 3 minus 9. What does 9 minus 3 give us? Good, 6. What does 3 minus 9 give us? Negative 6. So notice these are not equal. So it's not true for subtraction and division. This is only true for addition and multiplication. Questions on that? Alright. So our next property is our associative property. And again, I'm going to write that on this side. Associative. Alright, and again, this is true for addition and multiplication. And the associative property is just simply grouping things together using our parentheses. So if I have the quantity A plus B plus C, that's the same thing as A plus the quantity B plus C. Alright, so I can group A and B together, or I can group B and C together. With this term. Okay. So with numbers, 1 plus 6 plus 8 is the same thing as 1 plus the quantity 6 plus 8. So you're grouping it together. And then again with multiplication, A times B times C is the same thing as A times B times C. Same with our numbers. 2 times 1 times 9 is the same thing as 2 times 1 times 9. So again, all we're doing here is just grouping it different together. And notice again, this is only true for addition and multiplication. And notice you must be adding every single piece together. or multiplying every single piece together. This is not true for distributive property. All right. So we cannot say like 2 times 1 plus 3. This is not equal to 2 times 1 plus 3. All right. So notice here I have addition and addition. Over here, though, I have multiplication addition. So it has to be either all addition or all multiplication. Questions on the commutative or associative property? Okay. So next we have the identity property. Okay. Identity property. These are pretty simple. So for addition, our identity property is that anything plus 0 is just itself. So a plus 0 is a. And with numbers, 12 plus 0 is 12. So the identity property is whatever you do to it to get back itself. So for addition, in order to get back the number itself, you add 0. For multiplication, in order to get back the number itself, you multiply it by 1. So a times 1 is just a. 23 times 1 is just 23. Alright, so keep your identity the same. For addition, the sum of a number and 0 is just the number. So anything plus 0 is just that number. And for multiplication, the product of a number and 1 is the number. So sum means we're adding, product means we're multiplying. Okay. You're going to have to identify these properties. So again, it may seem trivial or very simple to you that 12 plus 0 is 12, but you're going to be asked to say this right here is the identity property. Alright, so next up we have our inverse property. And the inverse property is what you do to the number to get back to the identity. So basically it's the opposite. For addition, we're adding the negative version of that number. So a plus negative a is just 0. 19 plus negative 19 is just 0. So we're basically doing the opposite, the inverse. We're undoing it. Right, so multiplication. A times 1 over a is just 1. Looking at it with numbers. Negative 3 times negative 1/3 is just 1. Notice here both pieces had to have that negative. And notice it's a negative, they're not a subtraction sign. We can't say times minus. It's not possible to have two operations right in a row like that. So note these are negatives here. Right. And again, notice that we're getting back our identity. 0, we're getting back our identity. Right? So for this, we want to undo the operation. So let's undo the operation. It's kind of the opposite. For addition, the sum of a number and its inverse is 0. So the inverse of a is negative a. The inverse, when we're adding, the inverse of a, we multiply this one over. Multiplication, the product of a number and its inverse is 1. Alright, questions so far on what we've been doing? Again, these are things you knew to be true all along, but you didn't know that there were titles for it. That's what we're looking So after inverse property, we have multiplicative property of 0. I know it's a long name there, so I'm just going to write multiplicative. Multiplicative of 0. So this is a really simple property here. Alright, this is just simply the product of a number, and 0 is 0. So a times 0 is just 0. 0. A times 1 is 8. Negative 3 times 0 is just 0. So any number times 0 is 0. So this property is kind of easy to remember because it's called the multiplicative property of 0. Well, if you notice, we're multiplying by 0. So multiplying by 0. Alright. Then our last one is the symmetric property. The symmetric property. If A equals B, then B equals A. This looks kind of similar to our commutative, but we're talking about two things being equal to each other. Right? So if 1/2 equals 3/6, then that means that 3/6 equals 1/2. So that's it. So we can switch the left and right side of the equation. And notice we're talking about equations here. That means we have an equal sign. So we can switch the left and right side of an equation. That's the difference between commutative property, that very top one. That commutative property at the top, we're switching the terms themselves. Our commutative property at the top, we're switching these terms themselves, or flip-flopping those guys. Whereas for the symmetric property, we're switching across the equal sign. Any questions on that? Okay. So again, this is just a nice little foldable so that when you're doing your homework and you don't remember what is the commutative property, you can go to your foldable and flip it open and see what commutative property is. Okay. All right, so let's go ahead and take a look at notes 3. Alright, so we're taking a look at solving 1 and 2 step equations, and again, using those properties allows us to solve these equations, allows us to simplify terms on an equation. And remember, equations means that we're talking about an equal sign. We solve equations, we simplify expressions. Expressions is not. Do you have questions? Yeah. What's that? If you want, you can punch the hole on the side there and put that in your notebook, or if you just want to stick it in a folder, that's fine. Alright, so just a few more properties. The addition property of equality. If A equals B, then A plus C equals B plus C. This just means that we can add the same number to both sides of our equation. Okay, so I can add something to both sides of my equation. Good morning, Carol. Fancy meeting you here. Alright, so similarly with the subtraction property of equality, this is just saying that we're allowed to subtract the same thing from both sides. So I can have A minus B, or sorry, C, we already have B. A minus C is equal to B minus. Notice I'm subtracting the same thing from both sides. Right, then our multiplication property of equality. If A equals B, then I can multiply the same thing to both sides. A times C is equal to B times C. Again, notice I'm just multiplying the same thing to both sides. Right, and then division property. Again, I can divide by the same thing on both sides. So if A equals B, then A divided by C is equal to B divided by C. Alright, so all four of these is just doing the same thing to both sides. Both sides. It's extremely important that you do it to both sides. Anybody know why we have to do it to both sides of our equation? What does the equal sign represent? What does an equal sign mean? Equation. That they're the same on both sides. This equal sign means they're the same on both sides. So say that I had the equation, let's just go 10 divided by 2 is equal to 5, right? 10 divided by 2 is equal to 5. Well, if I suddenly add 2 to this side, but I don't add 2 to the other side, it's no longer the same, right? Because 10 divided by 2 is 5, but what's 5 plus 2? 7. So they're no longer equal. So you have to do the same thing to both sides. I'd have to add 2 to this side as well in order to maintain that they are equal, in order to keep that they are the same value. If I only do something to one side, then it's no longer equal, and I cannot have that equal sign. So I have to do the same thing to both sides to maintain that they are equal, to keep them as equal statements, the same statement. That is extremely important with solving for equations. Alright, so then our substitution property of equality. The key word here is substitution. Substitute. If A equals B, then that means I can substitute A in for B, or B in for A. Alright, so then A can be replaced with B. In any expression remember, expressions do not have equal signs in them. This is an equation. Each side is an expression. 4w minus 2 is an expression. Negative 2w plus 4 is an expression. So it can be replaced with B in any expression, equation. Equations have equal signs, so this entire thing here is an equation. Or inequality. Remember, an inequality has that inequality sign. So if I have less than or equal to here, that would be an inequality. Alright, so that means that I can substitute B in for A. And likewise, I could also substitute A in for B. You can substitute them in for each other because they're equal. Alright, so when we're solving our equations, we need to be checking our solution. So when we solve an equation, we're going to get an answer in x equals, or y equals, depending on the variable. That answer is called a solution. And what does it mean for a number to be a solution of an equation? A number is a solution if, when substituted in, an equation. So when we take that solution and substitute it back into my equation, it makes the equation true. So number is a solution if when substituted in the equation, it makes it true. So we know it's a solution if when we take that value, for example number 1, I'm going to take x equals 4, and by the substitution property I can substitute 4 in for x. If when I substitute that in, it makes this equation true, then I know it is a solution. If it doesn't make the equation true, that means it's not a solution. So let's go take a look at what an example of that is. So let's go and do number 1. I'm going to do number 1. Alright, so it says check whether the given number is a solution of the equation. So we don't know yet if it's a solution. We're checking to see if it is. So again, by the substitution property of equality, I can take 4, substitute in for x here, and over here. Alright, so I have a negative 4 times, instead of x, we have 4, minus 3. Does this equal, I'm going to put a question mark over it because we're wondering, does this equal negative x? But again, instead of x, I have 4, so negative. Let me erase this here. I was just pointing where we're starting. Alright, so again, I substituted 4 in for x. You can see I substituted in there, here, and here. And now we need to see if this is true. When we're checking a solution, do not cross the equal sign. That's an important note to make here. When checking a solution, do not cross the equal sign. Don't cross the equals. Because we're checking to see if it is equal. So we can't trust that it's equal. In order to cross the equal sign, you have to know that it's equal, but we don't know it is, so we can't cross it. So what that means is, I'm going to draw a line down there. I have to simplify the left side and see if it's equal to the right. Alright, so order of operations, PEMDAS. Alright, again, we're simplifying this expression here, the left side of the equation. So first I need to simplify my parentheses. So what is 4 minus 3? 4 minus 3. Freddie, what's 4 minus 3? Good. Alright, we still don't know if it's equal yet. I'm going to go ahead and bring this down. Negative 4 is just negative 4. What is negative 4 times 1? Negative 4. So they are indeed equal. So then I know yes, it is a solution. X equals 4 is a solution. Since it gave me a true statement, negative 4 does indeed equal negative 4, I know it's a solution. If it would have given me a false statement, let's say I got 8 equals negative 4, then that means it didn't work. It didn't make a true statement, so it's not a solution. So let's take a look at number 2. Again, I'm going to take 5, we're checking to see if this is a solution, and substitute it in for W. And again, we don't know if this is true, so 4 times 5, rather than W, minus 2, does this equal, and a question mark over my equal sign, negative 2, instead of W, I substitute in 5, plus 4. So again, substitute 5 in for W, 4 times 5, minus 2, does this equal negative 2 times 5 plus 4? Again, I'm going to draw a line there to help me not cross my equals. Alright, again, order of operations, PEMDAS. So let's simplify the left side a little bit. 4 times 5, okay, 20. Let's take a look at the right side. Negative 2 times 5, what does that give me? Good, negative 10. Alright, and then let's simplify some more. What's 20 minus 2 give me? Good, 18. And what's negative 10 plus 4 give me? Good, negative 6. Do these equal? No, they are not equal. So we know 5 did not make this statement true. It did not give us an equal statement there. So we know that this is not a solution. So no, W equals 5 is not a solution. Alright, so again, you check it by substituting it in. If it makes a true statement, then we know it's a solution. If it gives us a false statement, that means it wasn't equal. So then it is not a solution. Questions on that? Okay. So now let's take a look at actually solving equations. We've checked solutions. We've looked at the properties. Let's take a look at how to actually solve an equation. And again, we solve equations. That means equations have those equal signs, and we're solving, which means we're going to have a variable, an x, or maybe a y, maybe a w, some type of variable. Alright, so we want our final answer to be x equals, or w equals, whatever the variable is. We're looking for this here. We're looking for what makes our equation true. Alright, so our first thing we want to do is get rid of parentheses. Those pesky little things. Get rid of our parentheses. That might require you to distribute. It might require you to take care of your next exponent. It might require you to multiply or add. But you need to simplify your parentheses first. Get rid of those. Alright. Next, we're going to combine like terms that are on the same side of the equals. And this is a really important concept. We have to combine all the like terms on the left side, and then combine all the like terms on the right side. Again, don't cross that equals. We can't cross the equals until we do the opposite operations. We'll talk about that in a minute. Alright, so next we get variables on the same side. So this is when we are starting to cross that equal sign. In order to cross the equal sign, you have to do the opposite operation. So for example, if I have x minus 3 equals 9. In order to cross my equal sign there, I have to add 3 to both sides. Notice instead of subtracting, I am adding. So then I get x equals negative 3 plus 3 is 0, so I don't have to worry about that, they cancel out. And 9 plus 3 is 12, so I get x equals 12 for my answer. So notice in order to cross my equal sign here, I have to do the opposite operation. But when we are simplifying on a single side, so let's say, for example, I have 2x plus 3x minus 1 is equal to 9. When I am simplifying, combining like terms, then I don't do the opposite operation. I just combine like terms. So I can combine my 2x and my positive 3x, in which I would get 2x plus 3x is 5x, and then minus 1 equals 9. And then I could solve from there. So notice that difference. Here, I am combining like terms. Up here, I was crossing my equal sign, so I had to do the opposite operation. Alright, we'll keep emphasizing that. Alright, so first get rid of parentheses, combine like terms, and then get variables in the same sign. Alright, so next we're going to get rid of addition, subtraction. Then get rid of multiplication and division. Alright, so remember for steps 4 and 5, you're doing PEMDAS backwards. So you'll notice that we do the addition subtraction first, and then we do the multiplication division. Alright, so after we get rid of our parentheses and combine like terms, here's where we're doing PEMDAS backwards. Alright, and this is again when we're crossing that equal sign. When we're crossing the equal sign. So to get rid of addition, you do subtraction. Again, that's for crossing that equal sign. If I'm trying to get rid of addition, I do subtraction. I am undoing it. It's that inverse operation. To get rid of subtraction, you do addition, just like I did up here. I had subtraction. To get rid of it, I did addition. You have subtraction, you do addition. So we're doing the opposite operation, the inverse operation, whatever one does it. Alright, then to get rid of multiplication, you have an idea what we would do? Division, very good. And to get rid of division, what do we do? Multiplication. And like I said, these are inverse operations. Inverse operations, that's what we call them. They're operations that undo each other. So you can think of the word undo. Undo, or you might think of opposite. Do the opposite. Alright, and remember, this is extremely important here. Whether you add, subtract, multiply, or divide, you must do it to both sides. To both sides. This is very important. You have to maintain that it's equal. You have to keep it equal by doing the same thing to both sides. Alright, so in the end, our ultimate goal, what we're trying to do with all of this, is we're trying to get the variable isolated or by itself. Alright, so our goal is to isolate the variable. Which just means get it alone, get it by itself. So it looks like a lot of steps, but it's really not bad. Pretty much what we're doing with these first 3 steps is simplifying our expressions and then trying to get like terms together. Then in order to cross our equal sign, we have to do opposite operations. So instead of addition, subtraction, and vice versa. Alright, questions on that? Okay, let's take a look at some actual examples then. So on the back side. Alright, so our first one, number 3. It says solve, and notice the instructions say solve here. And we solve equations. Meaning there's an equal sign. So my final answer should be x equals, or a equals, or our last one, z equals. Should be our variable equal to some number. Alright? So again, solving equations. And it's an equation when we have that equal sign. Okay, so so let's take a look at this. Are there any parentheses to get rid of? No, no parentheses. Are there, if I take a look at each individual term, each individual expression, is there anything I can combine on the left side, x plus 10? Are there any like terms there? No. Is there anything I can combine on the right side? No. Alright, so there's no parentheses to get rid of. There's nothing to combine. There's no like terms. Alright, so we want to get x by itself. Well, what is there with x? What do we need to get rid of? 10. We need to get rid of this 10 here. Well, we have x plus 10, and in order to get rid of it, we have to subtract it. Good, we have to subtract the 10. Alright? So if I'm going to subtract my 10, what must I do though? What is it? Do it on both sides, right? We have to subtract 10 from both sides to keep it equal. Alright, so on my left side I just have x. Because positive 10 and negative 10 are just 0. Those cancel out. What's negative 8 minus 10? Go ahead. Close. Negative 18. Yeah, they're both negative. Alright, so negative 18. Okay. Alright, so my final answer should be just x equals. If there's still a number in front, then that means I need to do more. Right? So I have just x equals. That is my final answer there. X equals negative 18. If I check my solution, if I take negative 18 and put it back in, negative 18 plus 10 is negative 8, and negative 8 is negative 8, so that works. Alright, so let's take a look at number 4. Do we have any parentheses? No. Taking a look at my left side, are there any like terms there? No? No like terms there? Okay, so we don't have to do anything there. We need to get a by itself, that's my variable. So how can I get a by itself? Jason Velasco. Very good. We add 1/2. I need to get rid of my 1/2 here. We're subtracting currently, so I need to add my 1/2 to both sides. Alright, so I have a equals, because those cancel out. Now 9/4 plus 1/2. I'm going to do this up at the top here. Well, 1/2 is the same thing as 2/4, right? So 9 plus 2 is 11/4. You can use your calculator to help you out with that. And a is equal to 11/4. And again, my final answer should be a equals. Check that to make sure it looks right. 11/4 minus 1/2. Check on your calculator, it does indeed give you numbers. Alright, number 5. We have 3z equals negative 21. No parentheses. Again, no like terms. But what do we have to do now? Z is stuck with this 3. What are we doing with the 3 and z? What operation are we doing? What'd you say, Freddie? Well, what are we currently doing now? We're currently multiplying. And so to do the opposite, we have to divide. Right, so I'm going to divide by 3 on both sides. So my 3's cancel. So I just have z. What's negative 21 divided by 3? Close? Negative 7. Good. Negative 7. So z equals negative 7. And again, if I substitute this back into my original, 3 times negative 7 is negative 21, which is indeed negative 21, so that works. Alright, so these are our solutions. These are answers that if we substitute it back in, it will make the equation true. Also, this is the only number that makes my equation true. The only solution. Alright, so we can also write our solutions in set builder notation. This is everyone's favorite set builder notation. So instead of just writing x equals a equals z equals, there's a certain notation we use in math called set builder notation. Set builder notation looks like this. Alright, so we have these curly braces which are so difficult to draw, so just do your best with it. And we have the variable we're talking about, a vertical line, and then our solution here. Alright, so those curly braces mean set of. Alright, so we read this as a set of, and this tells us which variable we're talking about. So all x, set of all x. And this vertical line, it's a weird one. This vertical line, we read that as such that. Which means it has the following properties. And then we read this last piece as x equals 2. So we read this as the set of all x such that x equals 2. So all we're saying is our variable is x and the answer is 2. So we need to know set builder notation. You use it more in Algebra 2, which is why we're introducing it now. But it's pretty simple. You just write your variable, a vertical line, and then your answer. So let's go back and write our set builder notation for 3, 4, and 5. Alright, my set builder notation for number 3. The set of x such that x equals 18. And that's all you have to do for set builder notation. So you just put x in a vertical line in front of it. So then for this one, a such that a equals 11/4. And my last one, the set of z such that z equals 8. That's how you write set builder notation. Alright, questions on that? Okay, real quick I want to show you number 11. Just because it requires you to do more than one thing. So again, here we have no parentheses. We cannot combine like terms on the left side or the right side. So we can go ahead and start moving things across the equal sign. Remember, we do PEMDAS backwards, so I need to first subtract my 3 from both sides. So I get 16 is equal to negative 10. And then I can divide by 6. So I get t is equal to 10/6, which is 5/3. So make sure you do the subtraction addition first before multiplication. Remember that your homework is worksheet 5. You already have that with you. That is what's due next class.
And again, if you would like to get more points on your homework or classwork, you need to bring it like work tomorrow. And please pass this up to table.
Thank you. All right.
I need all my stickers on the front table, guys. Please do not put them with you. I do not have
Thank
that
you. On Blackboard, remember we have the videos of the lessons as well as the keys for the notes if you're not able to access the videos.
If you turned in late for today, come back and get it.
Sorry. Yes, Miss Charlotte, do you have your whole picture? She has it.
Okay.